we'd like to find a unit vector in the same direction as the vector v, which is -8, 15, and then we would like to find a unit vector in the opposite direction of another vector, also called v here, which is 9, -12. So separate problems. V in the first problem is -8, 15, and v in the second problem is 9, -12. If we notice the magnitude of v in the first problem is the square root of -8 squared plus 15 squared. The magnitude of a vector in two dimensions is the sum of the squares of the square root of the sum of the squares of the components. And this is the square root of 64 plus 225, which is the square root of 289. And if you're on top of your perfect squares, then the magnitude is 17. So this vector is 17 units long. If we consider the vector 1 over 17 times v, its magnitude will be 1, and it will be a unit vector, and I'll call that u. So a unit vector that's in the same direction as v, because we're multiplying this by a positive scalar, then it will be in the same direction. And the magnitude of u will be 1/17 the magnitude of v, and 1/17 of 17 is exactly 1. So the vector in question is the vector, I can distribute the 1 over 17 across the vector, multiply each component by the scalar. So we have -8 over 17, 15 over 17. This one is now a unit vector, meaning that it has magnitude 1. The magnitude of a unit vector is 1. That's the definition of a unit vector. By simply rescaling the original vector. You rescale by taking the original vector, there it is, and multiplying it by the appropriate constant that will make the magnitude 1, and that constant is 1 over the magnitude of the original vector. So the reciprocal, so 17, which is also 17 over 1, the reciprocal is 1 over 17 multiplied by the reciprocal of the magnitude of the original, and you will have created a unit vector in the same direction as the original. Okay, now let's find a unit vector in the opposite direction. So the opposite direction means we'll do just what we did in the first problem, but instead of multiplying by a positive number, we'll put a minus in there as well, and that will flip the direction. So first, let's find the magnitude of our vector so that we could see what number we have to multiply by to make it a unit vector. So the magnitude of v here is the square root of 9 squared plus -12 squared. And this is the square root of 81 plus 144. And that's the square root of 225. And the square root of 225 is 15. So the magnitude of the original vector is 15. If I want to make a unit vector, I'll multiply by 1 over 15. So 1 over 15 times the vector 9, -12. That would be a unit vector. A unit vector in the same direction as the original vector. So we want the opposite direction. So our unit vector, which I'll call u, is going to be -1 over 15 times the original vector. And if we distribute this through, we get -9 over 15, comma, -12 over -15, and let's simplify that. 9 over 15 is the same as 3/5, so this is -3/5, and 12 over 15 is 4/5. The negatives cancel. So there's our unit vector in the opposite direction of v.